Welcome back to my YouTube channel. So, we'll be dealing with the continuation of introduction to power series. That's where we'll continue. The last time we talked about what series is all about, sequence, the types of series and sequence, and we ended up with kind of a category of power series, which is the Maclaurin and the Taylor series, and that's where we're continuing now. So now, we say the general format for a power series is that y should be equal to sigma n starting from 0 to infinity a n x minus s naught raised to power n, and this is what we stated in our last class, and we defined each variable. And I explained that this sigma is helping to kind of condense the power series, which is in expanded form, right? Yes. So we understand that. So I want us to start from somewhere and get to where we are going. I want us to start from somewhere and get to where we are going. So generally, if x or x naught is equal to 0, that's the starting point, is equal to 0, we will have this y equals to sigma starting from 0 to infinity of a n x raised to power n. This is what we result to. So usually this x naught is usually 0, usually starts from 0, just like the origin. So now we have this. So take note of this. Take note of this. Now we can expand this to have the expanded form of this power series. But before we do that, I want us to look at how Maclaurin series and Taylor series can be expressed. Now, first, let us understand why are we even talking about this power series? Why do we need this power series? Why we need this is, for instance, if we have sine x, this sine x that we have, we don't know the value of x. Let's assume the value of x is 30. We only need our calculator to know what sine x, or which is sine 30, will give us, right? That is the. Now, what if we don't want to use calculator? How can we find the answer of this without using calculator? That is where power series comes in. So you can express this in a format that when you compute it, you will get the same answer that your sine, whatever, using your calculator will give you. But someone might not ask, since there is calculator, what is the need of following that long process? Yes, you can say that, but you should also remember that there are some because in this case now, where we'll be using this majorly is in series solution of differential equation. There are some differential equation that you can't solve. So it's not the case of just maybe having a function. This one is a solution that you can't solve with other methods. That you now need that kind of expression, that kind of series expression of that equation, so that you can be able to what? Find an approximate value. Are you getting me? Or result for it? Hope you understand the reason for the series itself. So this can be represented in a certain way, but let's not go into it. Let's talk about the general form of Maclaurin series. The general form of Maclaurin series. So look at the idea here. If a particular function, you know, this is my own function was what? Sine x, but it can be any function, right? So since it can be any function, I can say let that function now be the general format we normally use f of what? X, which some persons can say y. In power series, that's what I use here, y. I get in the representation giving power series. Okay? So in this our case, we are using f of x. Now if I want to express this f of x now, I can express it in form of a polynomial, right? Now if I want to express it in form of a polynomial, I'll start with a plus b of x plus c of x squared plus d of x cubed plus e of x raised to the power what? 4, okay, plus f x raised to the power 5. And take note that it keeps going because it's a series. It's a what? Series. What kind of series? Not just a series. What makes it keep going? Not just that it's a series. The kind of series. What kind of series? No. Infinite series. God bless you. So it's an infinite. It keeps going. It does not terminate. So this is the format that we can express this. This is the polynomial I get in the expression of this. So if I express this now, I don't know what is my A, what is my B, what is my C, what is my D, what is my E, what is my F. I don't know them. I get it. So I can't, there's nothing I can use this to do. So I just assume this. That for instance, I want to express something like this in a polynomial. This is how it's supposed to what? Look like. Do you understand? So this is how it's supposed to look like. Now for me to know how to get my, or what my A, B, C, that's the arbitrary constants, that's what we'll call them. What they will be. There is one thing I can do. First, for Maclaurin series, you know you start from 0. So Taylor series can start from any point. Usually why we say it starts from 1 is because once it starts from 0, it's now Maclaurin series. So any other place is starting from that is not from 0. We call it a Taylor series. So now, here now, we want to get our value of A. Let's start with A. The easiest thing I can do is to set x to be equal to what? 0. That means I'm looking for f of what? 0. I mean, right? Yes. If I look for f of 0, what will I have? I'll have a plus b 0 plus c 0 raised to the power 2. That's c 0 to the power 2 plus d, then 0 to the power 3 plus e 0 to the power 4 plus f 0 to the power of what? 5, and it keeps going. And discover that this will go out because it's 0. This will also go out, this will go out, every one of them will go out. Right? So what will we have finally? We'll have that f of what? 0 is what? A. So therefore, you can say that A is equal to f of 0. Do we understand? So if I want to find B, the arbitrary constant B, what will I do? If I put x in, it will still eliminate everything and still give me A back. I get it. But what I cannot do is what? I will not differentiate the function. I get it. So when the function shifts, you know the arbitrary constant will still remain the same. When you differentiate, the function is shifting. The arbitrary constant will still remain the same. So we'll have a f prime of what? Of x is equal to, what will it give you? If you differentiate a constant, which is a, what will you have? 0. Hope we know. If you differentiate a constant, you have 0. So plus, this will give you b. Hope you know. Plus, if you differentiate this, you have 2cx. Hope you know. Plus, if you differentiate that guy, you have 3dx squared. I mean, plus, if you differentiate, you have 4ex cubed plus 5f to the power of 4, and it keeps what's going. Right? I think I omitted x here. X to the power of what? 4. And it keeps on going. Do we understand this? So in this case, we do the same thing that we have been doing, which is to set the value of x to be what? What are we setting the value of x to be?
X to be 1.
No. There's not to set x to be in the initial case. We set it to be 0. Are you getting it? Because why I set it to be? If you set it to be 1, you will not eliminate other ones. So you are setting the 0 to eliminate other ones apart from the one we are looking for. So in that case, now if you set x to be 0, you have f prime of 0. We now give you what? In this case, b, there is no x there. So we'll have ordinary b, right? Hope we agree. So if I put 0 here, so that we don't waste time. If we put 0 here, what will happen?
Everything will be 0.
If you put 0 here, what will happen? 0. The same thing goes here, 0. And the same thing goes here, 0. Right? So the only thing we have is what? B, because B does not have X. Thus we say that therefore B is equal to F prime of what? 0. Do we agree? Please, if at any point you have a question you can ask. Then remember that we are here. Now, for us to get C now, we now get F prime of 0. Let's just do F prime of X first. So that when we put, we can now put 0 inside of it. So please tell us, what will F prime of X be? Call it out. F prime of X, what will it be from there? From here. Assuming I have not cancelled everything, what will it be?
0.
It will be 0 plus, okay? B, are you sure B? You are differentiating this thing again. This is differentiating this is already 0. Differentiating this is what will give you. If you differentiate this, I won't give you. If you differentiate everything now, it will give you 0. Are you sure? 2cx. If you differentiate, it will only give you 2c. Please, let's ask ourselves for differentiation. So here now, differentiate the whole here.
6 ds.
6 dx, okay, plus. If you differentiate the next, what will you get?
Yes, 12
12 squared. X to the power of 2, yes? Plus what?
20fs cube.
20f cube. X what? Cube. And it keeps what? Going. Now if you put 0, what will happen? Putting 0 here, what will happen?
0.
Putting 0 here, what will happen? Putting 0 here, what will happen? So this will get out, this will get out, this will get out, right? So we have that F prime of what? X will give you 2c. Right?
Yes.
So, no, we will not call it F prime of X because since you have put 0, it's going to be F prime of what? 0. Because we put 0 there. Right? So it is equal to C. So we can say, therefore, what is C? If I make C solve the formula, what will I have?
C is equal to 2.
C is equal to what? Make C solve the formula, what will you have?
2. C is equal to 2.
Are you sure? You are making C solve the formula here. F prime 0 is equal to 2C. And you are making C solve the formula, what will you have?
Okay, F prime 0 over 2.
Huh? It's F prime 0 over 2. Very good. Please, let's pay attention. Let's not be distracted. Now, we have this as our answer. Now, what if we move on to look for, we have gotten C, but we're here to get D, right? Please, take note. There is a temptation that you might have. What is that temptation? When you have gotten A, you already know that when you differentiate it, what you get next is B, so you began to just say, no need of differentiating others, let me just put it as what? As what? No, now when you differentiate, I have gotten A, you want to differentiate and you get B. Right? Okay, so you know you will get only B here, so you say, let's put other things as what? 0. That will be a very big mistake. You know why? Because if you don't differentiate other ones, you will not know how to get the next arbitrary constant because you will depend on what you got in this derivative for you to differentiate the next one. Do you understand what I'm saying? Yes. What I'm saying is, assuming you came here and after differentiating this thing and you got B, you now said, okay, for me to get C, let me just write 2C, let me just differentiate only the side, this C side, then take all that things as 0. If I want to do for the next one, now I need everything here for me to be able to differentiate correctly the next one. Do you understand? Yes. So if you don't do this one you don't differentiate every of the term, you will have the correct values to differentiate the next and find the next arbitrary constant. So now we're looking for D now. For us to get D, we will need F prime of X. So what will that be? I want us to do it together, please. This is basic differentiation, general differentiation, so it shouldn't be giving us problem. If you differentiate this, what will have? Okay, you have 0 here, okay? I agree. Plus, what next? Are you sure? If you differentiate this thing, you have 0. No, this one is not necessary. We are talking about this one because this we already know is 0. This place I'm talking about.
You have 60.
We have differentiated this to get 0. This is already 0, you know. Differentiating this, we have what?
60.
60. Okay, plus, for differentiate this, what we have?
You have 12 EX.
Are you sure it's 24?
Okay, 24 EX.
24 EX. Okay, plus
60
for differentiate, we have 60 FX2. Okay. So that is what we have. So for us to now be able to get the values, we will now need to substitute 0. So we have f prime of what? 0 is equal to, if you put, there is no s here, so you have 6d only, plus every other thing will go to 0. You put 0 again, 0, Abi. You put 0 again, 0. So this is equal to this, so no need of writing this. Right? So dividing both sides by 6. Therefore, d is equal to f prime of 0 all over what? 6. Do we agree? Ask your question, ask possible questions, ask possible questions. Ask possible questions, ask possible questions.
Don't leave me outside.
Ask possible questions. So, for us to get the next term, the next term is E now. E, right? We are getting E. So, for us to get E, we need F. This one we need to write IV. I can put it this way. IV. Right? So, I'm writing prime. And just write IV. It's acceptable.
We don't have a limited mass.
We don't have
a limited rate or number of not differentiate.
We are differentiating until we get A, B, C, D, E, and F. You can choose to stop in C self. But the only thing that your series, I told you something the last time we were explaining. You said, take notes for the online audience that when you get more series, are you getting me, to use as your representation for a particular function or equation, the answer becomes more accurate. The more series you get, are you getting me, the more the answer is accurate. So that's why it's good not for you to just go 1 and 2 10 or 3 10. It's up to like 5 depending on the case. So that it will be more accurate than what 3 will give you. So now, if we differentiate this one now, what we will have, remember we are here. So what will we have if we differentiate? We are differentiating this again to get prime. That's prime. Yeah. So what we have? 0 plus. Which one do we differentiate? This or this? This, okay? Differentiating this one we have 20 E, okay? Plus differentiating this one we have 120 Fx ordinary, right? So if you do F IV of 0, please take note that this is X of 0. Now what will we have? This guy will go to 0, only this 120 will go to 0 when you set X here at 0. So you now have 24 E, Abi? Yeah. So therefore what will E be? E will now be equal to what?
E will not be equal to
F
over 20.
Yeah, F IV of 0 all over what? 24. So if you want to get F, so you can get F, you can do F, you can pause the video and take for F. Okay? For F, what will we have? We'll differentiate again. So when we differentiate again, what will we have? You have F V of X. What will it give you if you differentiate this again? This. These will have 4. We're going to the fifth one. What will we get? You get 0 plus differentiating this one here.
That's 120F.
120F. Right? Okay. So if you set 0 here, it won't change anything because there's no X here. So what will you have? You have f of v of 0 now will now be equal to what? 120f. Therefore, f is equal to f of v 0 all over 120. So we are done. We are done. So what is the next? Next thing is to bring back your series. Are you getting me? And substitute the value of all the arbitrary constants. 1, which is still 2. Plus, what next? I have over 6. And we have concluded that it can be written as 3 times 2. So f prime of 0 x cubed all over 3 times 2. 3 times 2 can be written as 3 factorial. Because 3 times 2 can be, 3 times 2 can be also 3 factorial. Because 3 factorial is 3 times 2 times 1. Yes. And 1 does not change anything. So now we have that plus f iv of 0 all over. This can be written as 4 factorial. Because it's 4 times 3 times 2 times 1. And this is the same as 4 times 3 times 2. Because 1 does not affect anything, it's neutral, right? Is there any question? Any question? No. Okay, plus we have finally this, which is f of v of 0 all over 120, which is 5 factorial if you check. And it will keep forward going. So what I was trying to do is to express all the denominator in terms of what? Factorial. Why? In terms of factorial. So that it will be simplified. So the power series can be what? Can be simplified. Can easily simplify, generalize. Right? Okay. So we have this as our final answer. Okay. We can also, if possible, we can also do something if possible. There is something coming to my head. We can take this as a generalized form. Let's see what it will. We have sigma 0 to infinity. I will have f prime of 0 all over n factorial. Will it work? The only problem is that, okay, yes, I can change here to become n. Yes, beautiful. Please, this looks like it is very, very promising. It looks very, very promising. And the matter of fact, I just invented it now. Yes. Please, can we test this? This is a condensed format. So when you understand, one good thing about understanding this, if you understand it, you can formulate the condensed format by yourself. I have this formula now. Let's see whether it tallies with what we did. Let's talk what? See whether it tallies with what we did. Please, can you check it for me? Can you? According to what it says, let's see whether it tallies. Let's see whether it does. Tallies. So we have this now. So if you want to expand it, what will it be? To be equal to here now. We are starting from 0. Please let everybody be very attentive here. We are starting from 0. So if you are starting from 0, it means you have f. N here will be what? 0. So what this 0 means, this bracket, what it means is another way of representing derivative. It means the 0th derivative. The what? 0th derivative. And the 0th derivative that means it was not differentiated. It means what? You understand? The first derivative means it was differentiated once, right? So the 0th derivative means it was not what? Differentiated. So all over what? N factorial. What is our n? Remember, is what? 0. Multiplied by x is about what? 0. Plus, next value should be what derivative now will be? 1. God bless you. That's first derivative, right? Then all over here will now be 1 what? Is it not? X is about what? Are we following it? plus the next one will be what now? F second derivative. I mean all over 2, right? X to the power of what? 2 plus, let's see, next one will be what? F raised to power what? 3. Not, this is not raised to power, it's not the third derivative. So all over 3 factorial. X raised to power what? 3 plus F to what? Fourth derivative. All over what? 4 factorial. X raised to power what? 4. Let me write the x raised to power 4 here. X raised to power what? 4 plus what next now? F fifth derivative. All over what? 5 factorial. X raised to power what? 5. Please don't forget. There's something I omitted. Remember, 0 is always here. So I'm supposed to put 0 here, 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 put 0 here. So hope you know this thing satisfies this. So I was correct. So I just directed this and makes sense. So looking at this means the function was not differentiated. That means 0 derivative. That means it means f of the 0 derivative will still give you f. So this is same as writing what? F of what? 0. Writing what? F of 0. But it was not differentiated. 0 factorial, right? X raised to power 0 is what? 1. So I can clean it. That means times 1 is still the same thing. Hope you know it's satisfying. This one also is same. Is there any discrepancy? No. This one the same. Is there any discrepancy? No. This one is same. This one is same. So mean that what? This is the general condensed format of writing the Maclaurin series. Writing the what? Maclaurin series. So, but what you need to take note of, you can take note of this if you understand how to expand it. I mean, hope you know. You can take note of this if you understand how to expand it by yourself. So once you take note of this, it means you should be able to expand it. So that you don't stress yourself, you just know the condensed one, you can just expand it yourself. Or you cram this method. Hope you know that there's a pattern, there's a what? Check now. F of 0. All of them are usually f of 0. Whether it's prime, or 0 is what to be. I get to something as the independent variable. Hope you understand. Yes. So f of 0, the first will be 0 factorial. The next one, f of what do you call it? 0. The f prime of 0 now it will increase by 1 differentiation. Right? All over, it will now be 1. After 0, you enter 1, abi? Then the x here will have 1 power. Here, hope you know that x is 0 power. Which made it 1 now. Yes. So you just notice the pattern. The next one, you increase the derivative by 1, but the 0 will still maintain. X will now increase power by 1. The factorial will increase power by 1. It keeps going like that. So it's simple to what? To memorize. To what? Memorize. So this general form can be used to obtain the power series for any function you think of.